Yeah, I'm Steve Scargall. I'm the product manager for MMAI and CXL at MemVerge. But we're talking about CXL AI today. So this is kind of the high-level view of what we see as the MMAI product. We've kind of focused on the IT infrastructure guys, like Charles said. So the first column of labeled IT is the platform infrastructure guys, and then the users are going to be your data scientists, your researchers, your developers. So your question about how as a developer do I get access to this, what does it look like to me? Well, you shouldn't care necessarily what GPU is or where it lives or anything.
At some
right?
point, I have to access the GPU.
Yeah, so in our world, you just tell us what GPU you want, how many you want, how much memory you want, etc., and we go and provision that on the back end. So if you're working on a VS Code environment or a Jupyter notebook or Python, whatever it might be, right? You just say, give me an instance, launch it, and then we'll handle it from the back end. So, from that perspective, that's where orchestration and scheduling comes in, because we know what's happening on the back end with the infrastructure and how many GPUs you have, etc. And then we'll just make sure that your job launches.
Normally, I would assign portions of a model or things to a particular GPU, and there would be very specific allocations within the Jupyter Notebook or PyTorch or whatever, stuff like that. So that stuff now goes through you.
Yeah. So when we can show you a screenshot, but basically when you launch your workspace, as we call it, you tell us what type of GPU you want, how many, etc., and then we'll provision that infrastructure for you, and then your code, you can do with it whatever you want to do with it, right? So yeah, just going over some of the other features again. So some of these are kind of roadmap items. Some of them are in there today. Charles already talked about checkpointing. I'll cover it briefly, and then we'll let Bernie cover the deep dive later on. But in terms of the reservation and bursting, again, this comes back to how are we managing the infrastructure for all of the users that are out there? Typical cloud problem is you never really know who's going to want what and when. There's going to be bursty parts of the day. You're going to have batch jobs at night. You need to deal with streaming or real-time kind of workloads. So we handle all of that and really try to utilize the hardware that's available to you. So your earlier question, I'll cover this later about does MIG and MPS and everything else. So I'll cover that in a slide that's coming up here, and show you kind of how we can deal with that as well. We've got monitoring and all the telemetry stuff in there. I'll go in a little bit into the department billing. Charles covered this as well in terms of bursting and sharing resources. So, if you've kind of run out of your allocation, you can go and borrow somebody else's, assuming they have the resources available, and cross bill and everything else at the end of the day. So that creates what we call the kind of like a spot market type of thing. You can kind of beg, borrow, and steal and pay somebody else, but that resource might be taken away from you if the owner kind of wants it back for a higher priority job, etc. And then that gives us the ability for users, under the covers, to do what we call GPU surfing. So you can kind of move workloads around the different GPUs dependent on the availability of the resources. That's where we get the batch job runners again. The workspaces, the Jupyter Code, VS Code, Jupyter Notebooks, etc. And then of course you've got to kind of have a model directory or registry of where, are you just borrowing one, downloading a model from the internet and just deploying that? Are you fine tuning? Where do you store that? Is it publicly available, private registry, that type of stuff? And then on the very bottom here on the infrastructure side, like Charles said, we've started with Kubernetes because that's the most popular platform of choice right now, but we have roadmap items to get us into the Slurm and other deployments as well. And then of course we're cloud agnostic, so if you're trying to bring all of your AI on-prem, we support on data center stuff. If you want to run it in the cloud, of course, all the big boys have either Kubernetes as a service, or you can deploy your own Kubernetes and manage it. So there are lots of ways of kind of using our platform either on-prem and in the cloud.
So why do you need Slurm with all your capabilities? It seems like Slurm is much higher level and has less capability.
Right.
Platform.
And what we found though in talking to customers is that those that are currently on the training side tend to prefer Slurm, particularly those that come from a HPC kind of background. The inferencing side tends to be more on the Kubernetes side, but there are ways that you can layer Slurm on top of Kubernetes, or Kubernetes on top of Slurm, of course. So we can support them independently or layer them on top. So regardless of where you are today, we can get you kind of enabled, right?
But at that point, Slurm decides where the job goes,
Right.
as opposed to
Our
you
schedule.
really knowing where it should
right.
go.
Exactly, yeah. So that's the piece that we're working on. You know, one of the pieces we're working on
So is the goal then to use kind of a plugin where somebody makes a request in Slurm, it goes to you, and then you tell Slurm.
Right.
This
It'll be a connector type
Right.
interface. Exactly. Yeah.
Interesting.
Yes.
Steve,
Yes.
how about, you mentioned being part of VS Code. How about on the kind of DevOps tools, CI/CD process, or in the testing side of it,
Mhm.
taking the automation off there? Is that an API call to you, or how would that happen in an automated?
Right. I mean, we do expose our APIs. Product, the API service is available, so you could do CI/DC operations on that if you wanted to. You know, build it as part of your build pipeline or whatever
You're
you
just
need.
building it into your scripts or whatever
Exactly.
gets
Yeah.
fired
You
off.
call our API endpoint versus some other API endpoint that you would necessarily need to do on that one. Yeah. Exactly.
Okay.
Okay, I got a dumb question.
Oh, go ahead.
So, is MemVerge Memory Machine AI, is that software? Is it
It is software, 100%
installable software?
Mm-hmm. Yes.
But like so is it installable also on the clouds, or is it
Yes.
consumable?
We're agnostic. Yeah. So.
But is it consumable as a SaaS, or is it just software?
It could be a SaaS. I mean, we deliver the MemVerge piece really lives above Kubernetes. So we have CRDs and other bits and pieces, so we're completely Kubernetes
Okay.
native, right? So, but if you wanted to, if you had no understanding of Kubernetes, we also have the option of saying deploy Kubernetes and we put our software on top, and then you're ready to rock and roll. So
you throw out this clever term, GPU surfing. And so is the GPU surfing you're using an environment, you're making use of infrastructure. There are things around you that you do not have, nor do you care to have situational awareness of. Is the GPU surfing this capability of a developer not needing to know that they've been moved? Is
yes,
that simply one way to say that?
Yes.
Okay.
Yes. Yeah.
They just get to surf. They don't have to think about the surfboard.
Right. Yeah. They're running. In fact,
the web.
Yes. Let me see. Well, let me go through a few more, but I have a slide exactly on this, so hopefully
very good. Thank you.
I can answer your question a bit more. So, Charles covered a bit of this anyway, but again, we're trying to get the enterprises engaged in the productivity boost of all the hardware that they're buying or about to buy and got in the pipeline, right? So, certainly the customers that we've spoken to, some are only literally just getting started. So maybe they've got 1 or 2 servers with maybe a few GPUs in them, just to try it out, give it to their developers and see what they can do with it, right? So, that's certainly a target audience to us because there's some growth there, and we can. Not everybody has Kubernetes knowledge, or they don't really know much about GPUs. Maybe the developers certainly don't care to get down into the low-level bits and pieces, right? The developers they just want to start playing with code. So, improving the efficiency of the resources that they have, whether they have 1, 10, 100, 1,000 nodes, all with GPUs in, it shouldn't matter from our perspective, right? And going back to the GPU surfing, so that's where the uninterrupted operations comes from. So if I'm kind of working on my Jupyter notebook and somebody wants a GPU that I'm using and I can be moved elsewhere, right? There might be a short pause in service if I'm typing and it gets moved elsewhere, but I can continue uninterrupted effectively. And that's based off of our checkpointing technology, which is one of the key differentiators for our solution.
So are you saying that you pretty much have put together an entire MMU for the GPUs?
I mean, it's not an MMU as you would look at it in a kernel. We're just able to take a checkpoint of that workload and move it wherever it needs to be.
But it still needs to be in the local memory space.
I mean, you'll get all your page faults and everything else, but effectively, because our technology, our checkpoints include all of the host memory and the GPU memory and all the TCP stacks and everything else, so we can reinstantiate you back wherever it might be. So we might move you maybe to a different GPU on the same node. We might move you to a different node altogether, so long as you're in the same cluster, of course, But
okay, so this would be like along the lines of what VMware does with vMotion.
Very similar lines, yes.
Okay.
SRDF is what it makes.
Yeah.
Okay.
So does that mean, just thinking about what SRDF is, Does that mean that all the GPUs have to be the same, or they're like, what are the requirements on the hardware side?
Yeah, great question. So yes, if we take a snapshot on, let's say, an A100, you have to be put back on an A100, right? And that's in NVIDIA term, that's an NVIDIA restriction, not our restriction, right? I mean, because we take the memory dump, we have to put you back on the same architecture, right? I mean, if you were doing, let's say, PyTorch checkpointing, where you're just kind of dumping your state down to disk, well, technically you could be migrated anywhere, right? So long as your workload is to put it back on a GPU that has enough memory and compute and everything else, right? Ours is very much at the infrastructure level, at hardware level, so it's like for like, yeah.
So you're not really talking about model checkpointing per se. You're talking about application, movement and things like that.
Exactly. We kind of look at it from bottom up, right?
Right.
Like you say, where PyTorch would look at it top down and go, well, I'm just going to stop what I'm doing, take a
Capture a live model and move on. Yeah.
And then we don't care what that thing above us is. We just care, what the processes are, how many threads it has. We go off and dump all of its memory, save that to disk, and then restore it later on. So it's a slightly different approach. So
Yeah.
yeah. So as part of that, we've built a UI around this, so the platform admins have all the telemetry and everything else that they need as a end user, researcher, developer, etc. I've got access to my workspaces, so again, VS Code, PyTorch, etc. But one of the reasons that enterprises are doing this, like Charles said, is that it's all about data sovereignty, right? They don't want their data leaking out onto the web and doing all that sort of stuff. So they're bringing it all in house, so they have control over who has access to the data, where the data gets trained and all that type of stuff. So that's a key differentiator for where enterprises are focusing right now on training, fine-tuning, deploying of models. So when it comes to that, again, we kind of covered some of this anyway, but we're focusing on training and inference, right? And then being able to support multiple departments within the same corporation, same company on that same hardware, whether Department A has bought all the GPUs and allowing departments B, C, and D to use them, or if departments A, B, C, and D all have their own GPUs, they may have different types of GPUs, they may have different quantities dependent on budgets and constraints and everything else, but it might be that they just need more than what they can currently afford right now. So again, that's kind of part and parcel of our data movement. Again, we covered the fact that we're NVIDIA first, but AMD and Intel coming soon here. So, again, in terms of our target audience, our personas of who we're looking after, it's going to be infrastructure first, because those are the guys that have to go and set this stuff up, manage it, look after it, and service these GPUs and other things up to their end users, within the companies. So again, data scientists, developers, and decisions makers, all the CIOs and everybody else that has to go and figure out how many GPUs do I need, how many GPUs can I afford, when do I get them, how do I deploy them, all of that type of stuff.
So effectively, you end up presenting a management interface to the GPUs, allocation interface to the GPUs.
Yes.
You own the GPUs, and everybody goes through you to get to them.
Yes, effectively, the orchestration and the scheduling is effectively the piece.
And as far as the user is concerned, it's all virtual. They don't really have to understand which GPU they're using at any given time.
Right. Yeah. I mean, it's not a virtual GPU in as much.
In that sense, but yeah.
Yeah.
They really don't have to understand where GPU physical resources are being used.
Right. And it's no different than going to the public cloud and saying, I want an EC2 instance with an A100. I tell you which zone it's in, right? But I don't care which data center it's located in physically. I don't care which node it's in. All of that stuff is abstracted away from me. So, building on that,
there are conditions where there's, I don't call it data affinity, but requirements where the GPU has to be resident where the data is, et cetera, et cetera.
Yes.
You manage that sort of thing as well?
I mean, that's going to be part of the future orchestration variable inputs. I mean, there's a ton of them you can look at, right? That being one of them, and you can also look at the telemetry and put that back into the feedback loop and going, well, this node's overloaded, but this one over here isn't. So should I schedule new jobs over here or move stuff around? So, there's a ton of things that we're looking at that can definitely improve the scheduling and workload utilization over time, right? It's not necessarily that I land on node A and my job stays there for the duration of its existence, right? It may, but it may get moved elsewhere dependent on who owns it, the priorities, all that type of stuff. Right?
Can you, before you go on, you've
Sure.
used the term scheduling and orchestration quite a lot,
Mhm.
and I'm a little confused. Can you sort of expand upon what you mean by orchestration versus scheduling in sort of what you're doing?
Yeah, so the orchestration piece is really just managing the physical infrastructure, right? Understanding what I have out there, and then the scheduling is more of a real time. I have a user job coming in. What do I do with it based off of the infrastructure that I have around me?
And what is the actual connectivity? What does the actual thing look like? How are you moving workloads around? Where are those workloads running? How are you assigning GPUs? Yeah, what is is there an architecture diagram?
Not in this deck, but we can provide one. Yeah, yeah. I mean, fundamentally, it's Kubernetes, but
I think it will be obvious as you go through the demo.
yes.
Okay.
GPUs. Yeah, yeah. So let me move on. So now we're getting into kind of the fun stuff, right? So like I said, we align with the organization. So we have different levels of abstraction of how we present these GPUs up and how the GPUs are utilized and presented to end users. So everything belongs to the corporation, could be MemVerge, could be whoever. And then within each corporation, we have different departments. So in this example, I have engineering and production, but you could have QAT, test dev, a whole bunch of number of departments around. And then each department has its own number of projects, right? And that could be hundreds or thousands of projects around. So in this example, each department, engineering and production, have a knowledge base and a chat bot. But it could be as many as you need. We don't have a fixed limit on the number of departments or projects. And then drilling down one level further, so the GPUs are technically owned and managed by the projects and departments. So on this slide here, I have my knowledge base and my chat bot, and I have what we call node groups. So let me explain that a little bit. So within a physical server, I'm going to have some amount of CPU memory and some GPUs. They're all going to be the same within a node. Let's say you have A100s, H100s, and L40Ss. So depending on how many nodes you have, all of the nodes of the same type get grouped together. We call those node groups. And then those node groups are available to those projects dependent on how many resources they need at any given time. And then our scheduler, again, when workloads come in, will be routed through our scheduler and to the relevant node or node groups that belong to them based off of the resource allocations. So we talked briefly about bursting and stuff like that, and this is what this slide is trying to convey here. So we have three projects A, B, C, blue, green, and orange. So project A has 4 GPUs, project B has 4 GPUs, and project C has 4 GPUs. Project C is currently only using 2 of its 4, so it has 2 available. Project B is using all 4, and it's also borrowed 2 GPUs from project A because project A was also only using 2 GPUs at the time. So when it comes to snapshots and data movement and GPU surfing, this is kind of what we're talking about here, right? So we're saying that we can surf these workloads onto the GPUs owned by Project A, but if Project A has some more user workloads that come in that are of higher priority, these could get bumped out and they could go over to Project C, or if Project C didn't have any resources, we'd just queue them up and let them rerun at some future point. So
right, this assumes that all the GPUs are of exact the same type, right?
Correct. Yeah, this is within a node group. Yes, you are correct. So there was a great question earlier about does MIG and time slicing and everything else. How do we handle that? So I didn't include MPS, but for those unfamiliar, the MIG is the ability, as just to slice and dice that GPU up to 7 kind of physical partitions, right? So as far as we would be concerned from our level, yes, this is a physical GPU split into 7, but we can still use these MIG instances to put multiple workloads on top, right? So you're not necessarily isolated and limited to a single workload per MIG instance. We would treat them pretty much as we would do with time slicing and fractional GPU. It's just that they're a smaller GPU. Time slicing is just the ability for multiple workloads, in this case, workload 1, 2, 3, 4, to roll on and off each GPU, and each time it goes on, it has access to all of the compute and all of the memory for the duration that it's on the GPU, and then it's kicked off, somebody else is put on,
So you're not changing the MIG partitioning on the fly. You're using whatever the current MIG partitioning is and allocate within that. Is that how I understand
That's
that?
correct as of today, but there is a concept of dynamic MIG. So dynamic MIG allows me to change the number of MIG partitions on the fly, right? Obviously, there are some constraints around that, meaning the GPU has to be quiesced because I can't, again, NVIDIA limitations is I can't change this while something is using it. But if this is a quiesced GPU, I'm free to change that MIG instance and create whatever GPU size I need for as long as I need it, and then go back and change it at some future point. And finally, this is kind of one that we've put together, the fractional GPU. So this is one that NVIDIA doesn't give you out of the box. And this is the ability for us to, rather than do time slicing, where you may not be using all of the compute and all of the memory, we can bin pack effectively all 4 workloads onto the same GPU, assuming they all fit in terms of the memory and compute, etc. So workload 1 only needs 8 gig, workload 2 needs 2, workload 3 needs 10, and workload 4 needs 20. So I can easily fit that onto an A100 or something with 80 gigs.
So y'all keep track of that for all of the GPUs?
Correct.
Because that's constantly in flux.
Right. Okay. Exactly. Yes. So we manage this with the fractional GPU piece. So
it's got to be time sliced as well, right? Because things are.
It's not time sliced.
Fluctuating.
Oh. No. This is just the ability to run for the duration that this job needs the memory and compute.
So you're actually allocating a portion of the cores, a portion of the memory, everything,
Yes.
a portion of the GPU itself to a particular workload.
Right.
Or the extent of the workload.
Right. So
it's almost MIG without
MIG.
Flexible.
Yes.
Yeah, it just detaches that fixed relationship between cores and memory.
Yes.
So you can have more memory for a job that needs more and less memory. This is something that's really interesting because there's a lot of jobs that are much smaller,
right.
and you're just not going to use that
exactly.
at all.
Yeah,
okay.
and time slicing doesn't fix that because
wiggle your mouse on it so people who are watching online can see.
So yeah, this is fractional GPU at the bottom here, and then so yes, you're correct. It's a different way of doing job scheduling. The fractional GPU gives you the ability, hopefully, so assuming the job runs to completion and isn't kicked off and everything else, that you actually get the result faster than you would do with time slicing, right? Because you're always on GPU, you've always got compute. Potentially, it would finish the same time as MIG, assuming again
Let me be clear. So unlike MIG, which has a proportion of the HBM, the shared memory, and the cores, all those
fixed. Yeah.
With fractional GPUs, you can have half a dozen cores and half the memory versus the other 2,000 cores doing a quarter of the memory or something like that.
Exactly. Yeah. You can set it up.
Ditto with SMs.
Yes.
What's an SM again?
Streaming multiprocessor. So
streaming multiprocessor.
That's the compute part of the GPU, just like an x86 core is on the host side. So yes, we're able to. Again, you kind of have to give us the information up front, of course. The question earlier was, do you look at the models and can you determine all of the rest of it? So I think the answer in the future would be yes, right? NIM does this. You can kind of query the resources that particular NIM instance requires, and then you can go deploy it. So, but out of the box, right? As it stands today, you tell us again how much memory you want, compute on the GPU and on the host side, and we'll go configure it or schedule it, accordingly.
So does your schedule? How do you make this automatic and dynamic, right? So is there a way to do that, or is that doing that, or do you rely on writing it into the infrastructure as code part of everything? So how does
maybe
for example, let me give you an example.
Yeah.
So let's say we're banging away and we've got everything at full capacity, and a server starts to show signs that it's going to go down. Do you guys have a scheduler that you can write a schedule? You can write a workflow that says if this server gets to X percent memory in general, the server, or it's too hot or whatever, then let's go ahead and let's surf on over to another server. Or is that something you have to write from a Kubernetes point of view as kind of like a workload?
I mean, that's something that we would handle. That's part of our roadmap item. So
part of your what?
It's our roadmap item. So,
okay.
So we would look at the telemetry of the host, the GPUs and workloads, and then feed back into the scheduler so that you could more accurately
Dynamic, right.
decide. But again, with the ability to checkpoint and move stuff around as needed, right? Potentially, one of the things that we're looking at is, can I quiesce a node because I want to take it down for maintenance? Maybe it's got a bad DIM or whatever, right? I want to be able to quiesce it, but it's not going to go down right now. I can evacuate everything off at my leisure. I can schedule it for maintenance maybe overnight. I can put it back into service and then load balance back over time. So
Did you guys have to change CUDA to do fractional GPUs?
no, you don't have to change CUDA to do this. So kind of leading from your question, this is the priority and the preemption piece. So this is an example, and I'll show you a video actually coming up, but effectively we have two projects here, one with a high priority, one with a low priority. I have scheduled 3 jobs that are currently running on the low priority project. One is running, that's the blue hexagon in the left-hand side here, and I'm starting my job in the high priority. That's why it's currently amber, so it's starting pending. As it starts and it gets executed on the cluster, it takes priority. So we then preempt the low priority job that's running. We start the high priority. When the high priority job ends, then we can go back. There's nothing else in the high priority job queue, so we go back and just reschedule one of the low priority jobs. This is our dashboard, main landing dashboard, so it gives you kind of a sense as to how many nodes, how many GPUs, how much memory you've got out there, the workloads that are running, what state they're in, how much GPU, memory, CPU you've used, and we give you histograms for the GPU utilization as well. This is a look at the node group. So again, this is our abstraction of physical nodes all grouped together that have the same hardware. This is a look at the nodes themselves. So in this example, I just have a single CPU-only node, which is my management node, and a single GPU node with an A10 in it. But you can have as many as you have in the cluster. This is the department view. So again, I mentioned you can have as many departments within an organization as you care to have, and we show you how many projects and how many nodes and node groups are part of that department. So, again, from an infrastructure person, or if you need to talk to your CEO and you say, well, this department's using all the resources, please give them more or bigger budgets, whatever, this type of information is very helpful.
So I know this is new, but do you guys have RBAC in case there's like a bunch of people?
We do, yes.
Okay,
yes,
cool.
yeah. So RBAC allows us to split off all the platform admin, administration tasks and views and everything else for end users that don't really care about hardware and everything else that goes on underneath them. So yes, good question. These are just a list of example projects, I beg your pardon. And then, so the way that we're able to do all of the preemption and everything else, again, is done at the project level. So at the project level, you set up the priority of that given project. And what resources and node groups it has access to, and then at the bottom you can order them. So if you want to be able to use A100s first, and maybe H100s as a backup option, or vice versa, you can drag and drop. So you get the resources that particular project and team requires. We have billing in there as well. We mentioned all this bursting and all that type of stuff. How do you keep track of that? So we keep track of it on the back end. And in this example, I'm the project manager, so I was borrowing some resources from my engineering team because I don't have any GPUs of my own. Again, we'll give them all to the developers. So in this example, I owe the development team $10 for borrowing their GPUs to do my work effectively.
And that's pretty cool.
Yeah, so you can kind of see how this might work at an enterprise level, where again, project management team is important, but not as important as developers working on the core product that you need to ship, right? So, but I might still need some GPUs to do some work, and if the engineering guys aren't using it, why not let somebody else take hold of it and bill them at the end of the month or whatever? So,
or an MSP too.
Yeah.
Pretty cool.
You need a wimpy mascot says, I would gladly pay you Tuesday for a GPU today.
Yeah, so here's some videos just before I wrap up real quick here. I know we're running out of time. So this is our infrastructure as a universe galactic map type of thing, so I can zoom in and out. We have contextual telemetry, so as I hover over node groups and nodes and GPUs, the telemetry is based off of the thing that I'm currently looking at. So if I had 8 GPUs in a box or 100 nodes, I could figure out quickly which node and nodes were most utilized here. And we have the side menu that pops out to give you the graphical representation of the tabular format that we have when you hover over. So again, you're able to kind of drill down all the way down to physical node information here. So checkpoint and restore, this is one of the cool features. I need to leave time for Bernie to go over this. But in this example, what I have at the bottom here is a very simple training running in a Jupyter notebook. I can see the same job running in the top on our MMAI, and we jump into the Jupyter notebook as well there. And what you'll see is that I'm trying to show at the bottom that this thing is currently making progress until I suspend the workload. And then in the bottom section, you'll see that that job suspended. We get a notification from the client for Jupyter Notebook saying I can't connect to the server anymore. I'm showing you at the top here that the job is suspended from our perspective and that it's stopped from Kubeflow's perspective. And then I can restore that job back to a running state. And what you'll see in the bottom is that that job will continue from epoch 433, which is where I stopped it. So even though my code doesn't have any checkpoint information in it, I am able to continue processing that job without having to restart it. So if this was 2 days into a 5-day job, I don't have to go back to day 0 and start over. I don't have to build in all of that checkpoint stuff into my code because the infrastructure is handling it for me.
But it is documented because, like, if it's a really big job and it is, I don't know, like a clinical trial or something,
right?
You would want all that documentation and it moving.
Yep.
So it's documented and you can have that in your.
Yep. Yeah, we keep audit trails and logs and stuff. Yeah. And this is the workload preemption. So this is just kind of a video of the screenshot I showed you earlier, where I have my high and low priority projects. I've got 3 jobs running in low priority, and then I'm going to start a job in the high priority. It's going to kick out the low priority job, and then start the high priority. It's going to run to completion, and then when that job is terminated, my low priority job is going to come back in and start executing again. So that's a very brief introduction to what this video is showing us. So here's where I start my high priority job. So this is Kubeflow's interface, but we've just built a newer, more improved, what we call user workspace interface to this. So we're able to kind of select our image. It could be a custom image if that's what you wanted to do. You tell it how much RAM, CPU, and memory you have, how many GPUs you need, and what type of GPU you want. And then you have the option of enabling our checkpoint technology if you so desire. And then once that starts again, you'll see that the low priority job is terminated again using our checkpoint, and the high priority job runs to completion, and then we'll put it back on the queue. So there you can see that the high priority job ran. My 3 low priority jobs are now queuing. I can go in, I can start a very simple training job, the same training job I was showing you earlier. So again, it has nothing in there that says take checkpoints. I'm just going to change the epoch from 10,000 to 10 to make the demo run a little quicker. It runs to completion, and then when I shut this thing down, my low priority job is going to start again. So that's the job done. So here I can stop it. I don't need it anymore. I've done whatever I needed to do with it, and then I can remove it from the interface so it's no longer there. And then after a few seconds, you see it's gone from our UI. The pods have been destroyed, and then after a few seconds, we start one of the low priority jobs. So there you go. Now it's back and running again, and that would be doing whatever job it was scheduled to do. So with that, I thank you for your time. Do you have any further questions? If not, we need to hand over to Bernie. Go ahead.
What's your business model? I mean, are you gonna? It's not open source. Oh, is you gonna cover that, or I mean, how?
Business model?
Software product priced by number of GPUs we manage.
Okay.
Cool. All right. Well, thank you very much for your time. I greatly appreciate it. So.
Okay.
One quick question. Are
Go
you
ahead.
using any machine learning in any of this? I mean, there are lots of choices to be made by somebody.
That's a great question. That is something that we would love to do, right? We've got all the telemetry. We should be able to build models around this and make automatic, intelligent decisions for some of the scheduling and orchestration pieces. So yes, not today, but definitely on the roadmap for some of the items. Yeah, great question. Thank you.